Hi everyone, my name is Ozias Tosu from African Institute for Mathematical Science. I'm here to present to you my work on truth discovery. This work has been done with Lamine Ba from Université Alioune Dione de Bombay, Senegal. In this presentation, we will have these 4 lines. In first, I will present the study problem. Second, TDAC. Third, I will present an experimental evaluation, and at the end, I will conclude and present the perspective. In this work, we try to do the truth discovering on heterogeneous data by taking into account the different level of accuracy on the distinct group of facts. So the main challenge here is how to find the pattern so that we will have a group of correlated facts to maximize an accuracy of truth discovery. Let us try to explain in detail the problem with this example of the facts about 2 different topics. When we have in this example, we have many sources who give the answer for 3 types of questions. Here we observe that source 1 and source 2 are conflicted on question 1 for both topics. So the question here is, what is the truth? The second observation here is source 1 is accurate on Q1 and Q3, but not accurate on Q2. How to take now in consideration the behavior to find the truth? This is the main challenge in our work. Let us try to present the formal definition of the problem. Here, when we consider a set of sources, each source give a value about an attribute of object. So the truth finder, the truth discovery function here is just to find an optimal clustering P so that we will maximize the accuracy of the function F. To deal with this problem, we propose our method calling TDAC. The TDAC algorithm follows 6 steps. In first, we choose a standard truth discovering algorithm F. And the second, we generate what we call attribute truth vector, which is the main part of our work. In third, we make a clustering and estimate the K optimal. In 4, we partition our data according to the cluster. In 5, we execute our function in each subset of partition. And at the end, we test our criteria, which is just to test the equality between 2 different ground truths and go back to step 2 when we don't attain our convergence. Let us try to detail what we call attribute truth vector. Attribute truth vector is just help us to abstract the truth. Here, what we do here is we take an estimated ground truth, the candidate ground truth, estimated by our function F, and compare to each value given by one source about an attribute of object. If this is matched, these 2 values is matched, we put 1. If the values is not matched, we put 0. And if the source don't give any value, we put also 0. To measure the similarity between 2 attributes, we use the Hamming similarity distance. This distance helps us to measure the correlation between 2 pairs of attributes. With this example, when we use an truth finder function, which is a function almost used in the truth discovery problem, this function estimates the source accuracy and confidence value with these 2 equations. To partition our data, we use a machine learning algorithm which is K-mean. K-mean is an machine learning algorithm help to cluster our data by maximize the distance between two vectors when the vectors are in different cluster and minimize the distance between the two vectors when they are in the same cluster. To estimate the K of this algorithm, we use an silhouette coefficient, which helps us to estimate this K by using two criteria, alpha and beta, which is on cohesion and adhesion. After propose our method, we make several experimentation with different type of data. We set up many algorithm, baseline algorithm, and also we use 3 types of data sets and perform many metrics to compare the performance of our TDAC. For this synthetic data set, we use many kinds of parameters by knowing the optimal partition. In the result, we can see that our algorithm gives the best precision than acquisition partition, which is on first bridge method using the data partition. But when we compare to our ORAC function, which is the function who know the best, the ground truth, we see that our algorithm give in 2 cases the same result, and in the case he don't give the same result, but he give the result, the best result for all those algorithms. We compare also the partition given by TDAC with our data generator partition. We see that our partition is close to data generator. We try to see the impact of our algorithm with the baseline used inside this algorithm. We use an exam data set. In this data set, we have an answered question, and we synthetically select the file value in many domains changed by all the unanswered value. For the performance, we can see here that our algorithm with AQ perform very well than the baseline choosing. But in the case of true finding, he gives the same result with true finding. But this is because the AQ try to cap the accuracy of source. We use also on real world data set, which is stored on flight in our exam data set. In this data set, we don't change on unscreen question, and we see also the data coverage. We can say that our algorithm perform very well where the data coverage is very high, and don't perform very well where the data coverage is low. So at the end of this work, in this work, we investigate on true discovery problem on heterogeneous data by design an approach calling TDAC based on clustering machine learning. In this approach, we abstract the presentation, of the truth and give an efficient performance than the existing strategy for data partitioning. We see that also our algorithm use only one iteration, so the runtime is very low. For the perspective, we want to deal with space data or a high dimensional data. We want also to investigate with advanced clustering strategy. And also we want to reduce our algorithm time by introduce the parallel algorithm for this. Thank you for your attention. Your question and suggestion are welcome. Thank you.